A warm good evening class. In the previous classes we have seen the most important topic, failure mechanism. So we have seen what is failure, okay, what is fracture, what are the types of fracture, and eventually you have seen the some examples where this fracture mechanisms has been played has played a vital role, and even we can see the ductile and brittle fracture, right? So in continuing with that, if we see the fracture mechanism for brittle fracture, as like ductile fracture, there will be imposed stress, that the stress or load what we are applying. The second one is crack formation. The third one is propagation. But the main difference between the ductile and brittle is that in ductile fracture we can see there is some significant features before failure, but in the brittle fracture there won't be any notifications before failure. It fails, okay, it fails suddenly, and here these cracks are more unstable and the crack propagation will continue without an increasing in the applied load. But there is here there the crack growths only on applying the load. But here once the crack starts formed, even if you don't apply the load, the brittle fracture will happen, right? So the next one is so this is the ductile brittle failure. You can see this is the fracture behavior, where here this you can see if a material is like this, okay, on having on if the material is in a ductile manner, ductile material, you can see like this type of material will be have some reduced in the surface area or in the dimensions. So this type of happening is nothing but the necking process. So this necking will happens before the ductile material getting failed. So if you see this necking process, you can easily identify that this material is going to get failed in a ductile manner. We have to change the material immediately. But there will be a warning, means that there will be a warning before failure. But if we take a brittle failure, there will not be any warning. It will break suddenly, so we cannot rely on these materials, okay. So the third one is that here, okay, so how do this fracture evaluation happens? So the first one is that once the load is applied, you can see this pink arrow marks are nothing but the load is applied on the both area. So it will look straight. So once we are applying the load up to the critical limit, it will withstand the load. So once the critical limit is attained, the ductile materials will have the reduced. So this white is the original length or the original dimension. You can see some reduction in the surfaces, or reduction in the dimensions, or reduction in the reduction in the material. So that is known as necking process. So next are the necking process. If you are applying the load again, you can see the void nucleations that occurs, or the crack. This is the crack formations, okay. These are nothing but the cavities that are the cracks, okay. So even after this formation, if you are applying the load, these cracks or the voids will join together and form a big crack, okay. Like this way, right? This way you can see here like this, okay. This crack or the fracture getting formed, okay. Even after that, if you are applying the load, this fracture, okay, will get growth, or the propagation will takes place, means that the crack will get enlarged, okay. Once it reaches the surface, this enlargement, once it reaches the surface, even after applying the load, this will get sheared out or get fractured and looks like this. So this is look like a inverted. So this is the inverted cup, and then the saucer. You can see this fracture is getting happened. So the material is going to completely get failed. So here you can see this is the this area is nothing but the void formation area, or the void nucleation area, or the crack formation area. So after this crack formation, once it get failed here, if you see the surface, this inverted surface will looks like this. That is known as the cup and cone fracture. So you can easily find using the microscope if a cup and cone fracture with this type of thing is just known as ductile failure. So this is known as fracturographic fracture graphed area, or the this is the after the fractures happened, immediately after the fracture you have to see through the microscope. This through this fractalography you can see this, you can easily confirm that this is the ductile failed, this is material is failed through the ductile manner. Okay, that's all for today. Thank you and have a great day.